Everyone's playing it, and now everyone's arguing about it. What's the best way to beat Wordle? What's the best opening word? Well, MATLAB is here to help. Obviously, the best Wordle solver is one that uses MATLAB. I will be your MATLAB guide and interpreter for today because that's what I do. I'm Matt Turl, and I work at MathWorks making training content. My team makes things like the ever-popular MATLAB on-ramp and Simulink on-ramp, and a whole bunch more. And everything I'm going to show you today, the code is available. Links in the description below, as always. And now, obviously, I'm kind of jumping into this Wordle fray with what I admit is an inflammatory, clickbaity kind of title. But I do that precisely to call out the fact that there are plenty of arguments and theories about Wordle that are out there that very rarely ever discuss their assumptions or their terms. And I want to be totally upfront and open about that. So firstly, everything I'm going to talk about, I'm going to be playing on hard mode. So now I'm assuming you know the basics of Wordle, otherwise why you're here. But in case you don't know about hard mode, this is a setting that you can choose in which every word you play has to abide by the feedback you've received so far. So for example, if my algorithm plays slant and gets this feedback, then any following word it wants to play has to end in a T, can't include S, L, or A, and it has to have an N somewhere in the first 3 letters, can't be letter 4, can't be letter 5. Now, so obviously that cuts down the words that you can play, which simplifies the algorithm, and is generally a good thing to do, but it can also limit words that you can play to eliminate certain letters. So that's why it's hard mode. Now, secondly, what letters, or rather what words, do you work with? So Wordle will accept as inputs, or as guesses, a certain set of words, which is not every possible word or 5-letter word in English. So it accepts a subset of English, but then the words that it will use as a target word is a smaller set still. So there's a fixed list of 2,315 target words. And so I'm going to work with just that list of words. So I think of this kind of as an extension of the hard mode idea. So I'm only going to guess words that I know are valid solutions. So again, this does make the algorithm simple, but again, just like hard mode, it also does limit the ability to guess a word specifically for the purpose of eliminating possibilities. Okay, so those are the rules I'm putting in on myself, and based on those rules, now I want to build the best algorithm. Okay, but still, what does that mean, best algorithm? Algorithm should be self-explanatory, but I want something simple with as few heuristics as possible. That is, I don't want a whole bunch of like, if this, then that, but in this situation, if it's your third guess on a Tuesday, et cetera, et cetera. I want to just have an approach that will be to rank the words so that then I can just automatically pick one, picking the best one, and then playing the game is just repeating that, picking the word the same way each time from the list based on the feedback I've gotten so far. Okay, and then finally, what's our metric for best? I'm going to leave this a little fuzzy, other than to say that, yes, I want to win as many games as possible, but also in as few moves as possible. And these can actually be at odds a little bit sometimes. If you don't mind using all 6 guesses every time, then you could have a strategy to choose word combinations, to cover the most options and give you the best chance of getting it right by the time you get to the 6th guess. But if you want to use the fewest guesses, then you might have to be more aggressive. And then that could lead to words that might give a greedy algorithm a hard time. Okay, so those are my terms and conditions. So how do I actually do this? Now, the solution I'm going to show ended up being pretty close to one that was also suggested on the 538 website. And so you can compare what I've done with theirs. But the key insight there is that there's really no such thing as bad feedback. So in this example, yeah, it's great that we now know the second letter, but also knowing that the word has at least one D and one S in it, and no W and no R, that's also important information. It cuts down the possible pool of the target words. And ultimately, if you want to solve the puzzle as quickly as possible, you want to choose words that give you the best chance of cutting down the available words as much as possible. That's kind of a key point. Let me state it again. So the goal is we want to choose words that give us the best chance of cutting down the available words as much as possible. So on your first guess, you have 2,315 words to choose from. So what you want is to pick a word that will result in a much smaller pool of words for the second guess. And ideally, that would be regardless of what specific feedback you got. So let's think about this feedback. There are 5 letters, and there are 3 states: gray, yellow, green. Or if you prefer, 0, 1, 2, or any other set of 3 symbols or values. And so that means there are 5 to the power of 3, or that's 243 distinct sets of feedback that Wordle will ever give you. Now in code, you could represent that directly as a vector of values, as shown here. But a neat trick that can help to just keep the code clean is to reduce this down to a single value by looking at these as the digits of a number in base 3. Now, this does make the code nice, but ultimately it doesn't really matter how you label or order them. Just when you see my code, that's what you'll see. The important thing is that there are 243 distinct possibilities for the feedback. Okay, so over into MATLAB, I have a function that gives that feedback for a given target word and a given guess. Now, this is just recreating what Wordle would do. So if I guess, let's say I guess my example, they're words for a target of, let's say, solid. So I'll get the feedback that I was showing on the screen just now. Or I can add this extra flag that I added to do what I was mentioning and turn this into a single integer from 0 to 242. Else, if the target word was, I don't know, spray, then I get feedback option number 19. Remember, there's 243 options. This is one of them. And I could just do this ad nauseum, picking different target words, but this will get pretty tedious. The joy of MATLAB is what I could do, of course, is I could get MATLAB to do this automatically for all 2,315 target words. This is all 2,315 responses for guessing the word words. But remember, there are only 243 possible unique responses, and I may not have gotten all of them. So when we see what the distribution looks like, oops, and of course, sorry about that, I realized I didn't need to do that for each target word. So text words. Okay, and so you can see the distribution. I'll actually do that and force it to give me every integer value because I'm representing them as integers. Okay, and there you can see how many of each of the 243 possible outputs you get. You can see a bunch I don't get. And there are some ones that show up pretty commonly. And so you can see that if I guess words, then I've split all 2,300 target words into, turns out to be about 90 groups. You can see there are 533 words that will score 0, which if you translate it, that means 0 in each one, so that's 5 grays. And then there's another group here, so there's 276 that score 9, which again, if you figure it out, is a word with an R in the middle as a yellow, so an R somewhere, but not the third letter, and so on. So I've clumped into these different groupings, and you can actually get those values. And see how many of them showed up at all. And as I mentioned, so there's 90 different groups that do appear. So words has some overlap with, or splits the 2,300 target words into 90 different groups. And so thinking about that, now maybe we can start to build a strategy. So what would we like to see if we picked a really good word as our guess? Or maybe another way to look at it, and I think this can be a little easier to answer, what would a bad guess look like? What would this distribution look like? Well, the worst possible result would be if every possible target word, for whatever my guess was here, gave me the same feedback. Right? Even if that feedback seemed good, it had lots of green and yellow in it, that's not great because now I haven't cut down that pool of possible guesses at all for my second guess. I'm pretty much no closer to the solution. And so flipping that around, the best word to guess then would be one that returned all these possible responses equally, all 242 options equally. And that may seem a little counterintuitive that you want to get the same chance of getting every possible bit of feedback. But think about what that means would be that whatever the target word was, the feedback I'd get from this magic first guess would tell me which one of the 243 groups that it's in, and each one of those groups, if I start with 2315 words, and I split it into 243 groups, then every one of those groups only has 10 words in it. So if I had this magic word, I make one guess, and I'd immediately bid down to 10 possible words from then on. Right, so this would cut things down and speed up my guessing really, really quickly. Okay, so what is this magic word? Well, of course, it doesn't really exist. Words don't work that way. But if I can calculate this distribution for one word, this was for the word words, then, I can do it for another, right? I could go through and repeat this for some other random guess. What if I wanted to guess, I don't know, acorn? Why not? That's a good word. All right, and then I could go through again and make my histogram, right? And I get a different distribution, and maybe that's a little bit better. It looks like maybe there's more spread out bars. And in fact, again, I've got MATLAB, I've got a computer to do this for me. I could do this, what I've just been doing manually, for every possible word, every possible guess. All right, so, and if I do that, my result will look like a matrix here. But let me do this kind of more symbolically. The result will look something like this, right? A record of all the responses you would get when each word was guessed with each target word. Now, so remember also that these values, they're just a shorthand. They're just a way of representing each possible arrangement of gray, yellow, and green. So 99 isn't better than 55, right? The numeric values don't mean anything. It's just a different arrangement of green, yellow, gray, yellow, and green. But what this is capturing is simply the relationship between each pair of words. So in MATLAB, I have this kind of preparatory script that gets the word list, and then it goes through every pair of words, every target and every guess, and gets the response, the Wordle score, for each one with the other as the target. And so here's the full matrix of 2300 by 2300 scores. And then the kth column of this matrix gives that full list of scores for guessing the kth word for every possible target. So the distribution of this column, that's what we were looking at before with the histogram. So that gives us a way to rank how good is this kth word, how good a guess is it. And now here there is a little bit of ambiguity. So you can argue this, which is, what is the best measure of how even this distribution is? Remember, that was the goal, is the most even distribution would be the best. So you could look for the lowest maximum value. That would hopefully spread things out. You could look at variance. You could look at expectation values. You can even do like information theory, entropy stuff. Or you could just look at kind of the coverage, which is how many different possible responses do I get? Because remember, there are some where there is no overlap. There's no response that I get. And interestingly enough, this is kind of seems a bit weird, but if you're trying to play the game of guess the word in only 2 guesses, then you could actually mathematically prove that this last option is the best. And that's what's in the 538 blog. They go through that argument, so you can go read the details there if you're interested. Now, with more than 2 guesses, with up to 6 guesses, it's not as obvious what the theoretically best approach is, but you can try this approach. We can see how it does. So, let's go to my actual playing function. So this is a function that plays a round of Wordle. So you give it a target, you give it that starting list of 2300 words, as well as some derived information about those words. Now, I'm passing these in as arguments to a function, just because it's better to calculate these once, and then in the function throw away the ones as I narrow down the choices, rather than to keep recalculating them each game. That's just inefficient. So just to keep the code running a bit faster, I'm passing them in. And you can see that one of the things I am passing in is that matrix I was mentioning, the matrix of all the scores of each target versus each guess. You may notice that I haven't said anything about probabilities or letter distributions. And that's a common approach that people use. And in fact, Adam Fillion and myself both wrote blog posts for Lauren Shore where we took that approach. So it is very common. But as it turned out, I found that this idea of looking at the combinations of feedback actually works better. That said, I am including probabilities here just to use as a tiebreaker in case 2 words or more than 1 word have the same number of different feedback against all the targets. So this code now just runs through the algorithm that I kind of sketched at the beginning. You can see it just says, okay, until we're done with the game, apply the feedback that we have so far to cut down the words to only those that are valid under hard mode, right? So we're matching the green letters. We then make sure we're including the yellow letters, and then we're cutting out the gray letters. And then once we've cut down to only valid words, then we take that matrix and we use it to assign a value to each word, and then we can choose just the highest value word. And here's where I'm using the letter probabilities to pick the most probable word if there are multiples. And that's basically it. We pick that word, we play it, we get the feedback, and then we go through, and the rest of the code here is just going through the feedback to update our information for then on the next step when we need to select a word. And we have to go through all the cutting it down again. If you want to download and look through this code, I'll just mention to help make sense of how I'm doing this. I'm keeping a kind of a list that is the lower, or two lists, the lower and the upper bound of every letter of the alphabet. So at the beginning, you'll see they start at 0 and 5 respectively. And then I'm using the feedback to pull those bounds in. And so then to go to look at the at what words are available, and you'll see then I'm now just looking at which words have the number of letters in between those two bounds. Okay, so hopefully that'll help if you try and read through my code. Okay, so then let's give it a shot and let's see how this plays out. So we'll get wins, the number of guesses and the list of guesses. Where, I don't know, let's say our target word happens to be water. All those derived quantities here, and okay, you can see the algorithm, well, it solves the puzzle in 3 steps. First it guesses trace, then alter, and then water. Nice job. And again, I could play this manually with some other target word, or of course what I could do is now just set this running on playing all 2300 games with each word as the target. I won't run this because it takes a couple of minutes, but again, this code, you can look through it. But you can see I run through every possible game. It takes a couple of minutes on my computer, and it does pretty well. It wins pretty much all the time, mostly in 3 to 4 guesses. You can delve into the algorithm's choices a little bit here too, and you can see that it always guesses the word trace first, and then the second guess, of course, depends on the feedback, and then the most common response is actually the all grays, right? No hits, which happens about 11% of the time, in which case it then guesses slimy. And you can kind of see the whole strategy if you really want. And you can also look at the handful of words that it's getting wrong. It only gets 9 out of the 2300 wrong, or ones where it loses the game. And you'll see it kind of fits into a certain set of patterns. There's about 6 word letter patterns that it's getting wrong or it's having difficulty with. And it's could be kind of informative to look at that. You can see some of these patterns are just hard. Remember, given that we're playing on hard mode. So there are 29, let's see here, there are 29 words of the form something A, something ER. And so if you've got 29 of those possibilities, you can see it's just really hard to eliminate. After you've settled on that pattern, there's just still too many options and then you just run out of guesses. And similarly, you know, a word like watch, this really shows why hard mode is hard. Right, so look at this, 2 guesses, and you're nearly done. You're like, wow, I'm winning this easily, right? I've got 4 of the 5 letters bang on. But this is the problem with hard mode, is now I've only got 1 letter to play with. And so I just have to go through each one in turn. There's no other option. And so there's going to be some that you just run out of guesses before you can cover all the possibilities. Now, if you're not on hard mode, your third guess could, for example, be blimp. right, which would actually either give you the remaining letter or eliminate 4 of them in one go. So that's why I said hard mode, mostly pretty good, makes a simple algorithm, but has some nasty little catches. Now, for all of this, I've been using the ranking method of how many unique responses the word gets against all possible remaining targets. In other words, how many non-zero bars in that histogram. I did say you could try other methods. This one gave me the best results. So at 2,306 successes out of 2,315 games, I'm going to say that, yes, I do in fact have the best algorithm possible, at least under the conditions I laid out. And I'll leave you with a visualization that I made, and I was really just copying the one from 538. Now, they were not restricting to just the target words, so their results are slightly different to mine. But this is the strategy for the first 2 moves. First move, just guess the word trace, and then the word around the outside is your second guess, according to the feedback that you got from trace. And I've actually used this little visualization playing Wordle as a human in real life, and managed to get actually two guess wins in a row. So I'm feeling pretty good about it. But all this code will be available online, links in the description below, so feel free to go grab it, play with it, and if you like, go on, try and prove me wrong that this is the best Wordle solver.